In this part of Chapter 17, we're going to look at titrations. In the next couple of videos, we'll take a deep look, both qualitatively and quantitatively, at what a titration can help us do. So the most common type of titration is between an acid and a base, but other kinds of titrations also exist. Oxidants and reductants, giving you oxidation reduction, and ones where a precipitate forms are also popular. So there's two reasons to perform a titration. One, to find a concentration of an unknown, or two, to find the equilibrium constant of an unknown. This is really popular in an acid-base titration because then you can identify an unknown acid or base. There are four kinds of titrations in the acid-base titration world. There is a strong acid, strong base titration. There is a weak acid, strong base titration. There is a strong acid, weak base titration. And there is a weak acid, weak base titration. We also have the possibility of having a reaction including a polyprotic acid. So a polyprotic acid, remember, is one that has more than one hydrogen atom attached to it. We'll look at that in a lab. So titrations are monitored with a pH meter or pH probe, and it creates a graph of pH versus milliliters of titrant. The graph will end up looking something like this, starting with the acid in a beaker. pH will be monitored on the vertical axis, and then milliliters of titrant that are added will be graphed on the horizontal axis. The physical setup of this looks like this, with a beaker that usually contains the acid, and then there will be a burette or some type of delivery system that's really accurate to the number of milliliters that contains the opposite, in this case the base. And then the base will be added dropwise to the acid, and there'll be a pH probe or a pH monitor in the solution, and it will tell you the starting pH, and then it will monitor it after every little milliliter amount is added. You'll notice the real steep part to the curve right here, and that's where a special point occurs that we'll talk about in a second. This special point is called the equivalence point, and it's where there are equal moles of acid and base present. It usually happens in the middle of the steepest part of the curve. We'll take a deep look at the mathematics of this next. Two examples follow, one with a strong acid, strong base titration, and a second one with a weak acid, strong base titration. Lots of details in the future.